non-collinear, Conon calculations. So definitely I will cover up all about the comparison. Participants, I will cover all the features comparison. This is completely 5 days programs. Okay, so you will get to learn a lot of things, but I request you to give your time. I will compare you with our software with other competitive softwares so that you will find some
यूट्यूब लाइव वाला लिंक भेज दो सबको। ऐसे करेंगे तो फायदा क्या होगा हमारे पेमेंट का? क्यों? अरे तो हम लाइसेंस थोड़ी दिए, हम तो ऑडियंस को दिखा रहे हैं, डेमो दिखा रहे हैं। कौन सी बैच ये नो
comparison with
मजा आ रहा है ये बता दो मुझे।
BAS or any other.
नेटवर्क तो अच्छा खासा
Simulation software, two-port device simulation, anode and cathode diode simulation, and transistor simulation, which cannot be done in BAS. So that will come discussed in the coming time. So that's why keep patience and attend it properly, and we will clarify all your doubts related to the competitors. So if we talk about the general So the journey was started from McGill University in 2008, where they have developed some quantum transport calculation tool, which is supported by Northwestern University in 2002. And then in 2008, the company was formed as a commercial, and they were developing the quantum transport device calculation. The NANODCAL software will be there that we will discuss in the coming time. So that company were developing device simulation software. Parallelly, the materials with the perturbation theory is implemented from 2015, so that you will have also some user interface that is called Device Studio. The user interface Device Studio was developed in 2016, so the user can model the structure by plug and play instead of scripting, writing the code. If you are mismatch something, then it will be very time consuming. So that's why the user interface integrated with the background simulation code is also developed. Even in the coming version, coming time, Rescue Plus version with Python is also being development, so that you will get more enhanced, more faster calculation speed. Now, if we talk about the next slides, that is called material and devices. So BAS only works on materials application, not for device applications. But we have two packages. One is called Rescue that we are discussing today. In coming session, we will also discuss about NANODCAL. Rescue perturbation theory. So these are two algorithm in this rescue code is implemented, which is very sophisticated approach where user interface will be there. You can define different algorithm solvers are there. What will be there in coming time, you will get to know many things. And NANODCAL with a background calculation engine that will perform for device simulation and transistor simulations. It is very effective tool for different problems. Realistic physics with different complex material, we can try to build and get it simulated. Now, if we talk about what kind of materials, what kind of devices, properties you can calculate. So basically, there are three things in every software. One is called pre-processing, where you can model the structures, you can manipulate your atomic structure coordinate points, and then you can define some DFT calculation parameters, some theoretical equations, theoretical models. So advanced builder is there. We have a building tool that will help you build your structure. So nanoscale builder is there. user-friendly setup parameter simulator is there, where you can define some DFT parameter, some electron temperature, energy cutoff, K-point sampling, spin orbit coupling, and many more things you can define in this setup calculator. And once the simulation is done by using either rescue or NANODCAL, you will find the visualization of your output in our own visualizers. You can calculate various property at material level, electronic property, structural property, optical property, thermal property, magnetic property, electron and thermal transport, electron phonon couplings, and even device calculation, current voltage curve, IV curve. Our software can calculate IDBD transistors calculations. The software can also perform, and photocurrent, and many more property will be there. We will come in the coming time. You will get to know many of the things. How it is value for money. Now, what kind of different materials the software can build? The software can work on molecular applications. Either you are going to simulate benzene, double benzene, or different complex molecular structures. That is possible. We have a molecular builder. You can build your molecule by defining some chain. Different chain can be created. So molecular builder will be there. Either you can define some coordinate point and you can create your builder. And we have a user interface to draw the molecular structures. The molecular structure, device structures, surface. You can define some surface planes. Surface where you can define some 100 plane, 111 plane, 000 plane, or any surface plane. You can also define some different complex structures. You can define some lattice parameters, some alpha, beta, gamma, ABC value, rhombohedral, hexagonal, tetragonal, triclinic, or from different space group, 1p1, 2p1, 3p2, different space groups you can select, and you can create different kind of lattice structures. I will show you in the live how it can be done. So presentation is just to show you the what feature software exists. How it can be done, that will come in the demonstration session. You can also perform some interface structure where you can take two different materials. Let's suppose silicon germanium, gold silver, aluminum, gallium and arsenides, or any other two complex material. The infrastructure, the interface can be created. Molecular junctions, molecular based devices, where one will be the anode, right will be the cathode. In between, there will be some molecules. It could be benzene or it could be any other molecules will be there. So you can define that molecules. Some two-dimensional material-based devices, where you can define some material. Let's suppose you have a MOS2. So that MOS2 you can create the nanostructure, and then you can assign some left electrode, some right electrode, and then two probe device you can simulate it. If you want to define some gate also, the transistors, then it is also possible. Even this is a complex material, you can create a complex chain of the carbon material, that is also possible to build it. So basically this is a particular domain, the software can work on it. So people are working and using this software for a variety of applications. Similarly, you can also test how this software can be beneficial for your existing research. So now, if we talk about the theoretical parts, if we talk about the rescue features, the rescue is having some basic sets, some exchange correlation functions. So we have the LDA, GGA, meta GGA. So these are basically exchange correlation function. Meta GGA, which will help you to calculate the accurate band gap in semiconductors. Hybrid forms, POC exchanges are there, EX are there, HSE06, B3 L by P, collinear spin, non-collinear spin, spin orbit coupling, and spin rho theta phi, you can define it. So you can see here, this is DFT theoretical parameters, where LDA is there, GGA is there, meta GGA is there, EXX with correlations are there, EXX with partial exact correlation is there, chemical accuracy. So based on different vacancies, you can create this basis sets analysis. Now you can simulate the periodic structures, symmetrical structures, symmetrical relaxations, band structures, band unfolding, density of state, projected density of state, local density of state, Mulliken population, Bannier functions. So you can see this is the band structure for I2 TI2 for based on numerical atomic orbital and real space methods. So real space and numerical atomic orbital method, the band structure are calculated and density of states are calculated. So based on two different algorithms, we can calculate the electronic properties. So this is all about the basic features. If we go beyond the DFT, we have a perturbation theory, that is a toolbox or response functions. Yes, I would like to say you the software will also be helpful for transport calculation, but not the rescue. We have a NANODCAL software. We will also cover the session on NANODCAL that will cover the quantum transport calculation for MOS2 based devices. Rescue is specifically designed for material. So today's session is basically will work on material application, but coming to second day, third day, 4 days, that will also cover on the devices application as well. So we will provide you a complete solution from material and material to devices. So this is another algorithm perturbation theory that is for toolbox for response functions for Raman property, optical properties. From response to perturbation, electrical field, incoming photon, outgoing photons, temperatures, some third order non-linear response, different algorithm, different BICG and CFSI solvers are there that will solve the density functional theory algorithm. You can calculate the end clamped dielectric constant, vibrational, phonon calculations, properties, low frequency optical analysis, non-resonant Raman spectra, non-linear optical susceptibility, electron phonon couplings, phonon band structure, phonon density of state, Born effective charge, infrared intensity, IR intensity, dielectric permittivity, complex refractive index, energy loss, oscillator strength, tensor susceptibility, intensity, and scattering time mobility. So related to the perturbation, Raman optical energy loss, phonon calculation, then this rescue tool is also there. But this rescue code is at material applications. Those who are working at device application, then we have a NANODCAL software that we'll discuss in today's or maybe in coming sessions. So that's why it is a complete 5 days program where you will learn a lot of things. Only the thing is we require your time so that we can give you a complete analysis about the software so that you can explore it completely. Now, if we talk about the more theory about this DFT, it can calculate the dielectric constants. Let's suppose many people are working on material application, many people are working on device applications. But the device will ultimately can be formed with the materials. And we can calculate the material characteristics, we can calculate the device characteristics. We have a different combination of material analysis. And then material property can be assigned or can be used in the device calculations. So like, let's suppose you want to calculate the dielectric constant. You want to calculate the refractive energy loss. You want to calculate the refractive index. Then we have this, you can see, this is some dielectric constant we have calculated for carbon, silicon, aluminum phosphide, silicon carbide, MgO material by using this rescue. The dielectric constant was calculated, and that dielectric constant may be used in TCAD device simulations in Centura, Silvaco, SatFos, Crosslight, Kujenda, in many of the software. That's why the material simulation, you can use this software. And even for the atomistics-based device simulation, we will also have. We have different algorithms. So we have simulated the single materials and large number of atoms. You can see the 2 atom, 16 atom, 54 atom, 128 atom, different atomic algorithm. We have simulated 12 core Intel 2.4 gigahertz boron nitride dielectric constant is calculated. So number of atoms based on different this PCFSI solver that will increasingly outperform conventional solver as a system size grow. Whenever the number of atoms grow, the calculation time increases. But we have the solver that will try to make outperform. The algorithm inherently are more parallelable, low memory requirements. So the experimental simulation and theoretical prediction based on this accuracy, we have calculated around 90%, 2%, we can get the predictions. Now, if we talk about what other properties, electronic structure calculation, density of state, band structure, that is possible. Raman property, optical properties, phonon density of states calculation, that is also possible. For IV calculation, transistor calculation, we have a separate tool that we'll discuss later on. Now, if we talk about the perturbation, phonon calculation and density of state, we have this experimental data with the dotted lines and simulation results. Phonon band structure for FCC diamond crystals. This is Brilliant-Jones root point G, K, U, X, G, L, and we have with frequency variations, we can calculate the phonon analysis. And this is supercell structure, diamond phonon band structure, 216 atom. We have calculated the density of state with the frequency variations with 8 atom, 64 atom, 216 atoms. So the simulation time can also be differ based on the system size, number of atom, and accuracy point of view. The software can work on low frequency, long wavelength, optical properties also, because ultimately those who are working at device, the device can be formed with the material. The device ultimately use the dielectric constant. It use the refractive index, NK data, real and imaginary data. So that data, that material property, we can calculate first by using this rescue software. That's why you can see the dielectric permittivity, we can calculate the real part, and eventually we have calculated and simulations by using rescue, we perform around 90% accuracy based on theoretical model we can get. So this is hexagonal aluminum nitride, dielectric permittivity and refractive index, real and imaginary part are calculated. So this is all about, here you can see the energy loss in infrared intensity oscillator that we can calculate. So IR intensity on oscillator strength, we can calculate with different material, with different algorithms. So in the coming slides, let's suppose you are working on perovskite material at material level, not talking about device level. So perovskite structure is there. The structure be already available in our database that you can implement, or you can also define your lattice parameters. We have a builder is there where you can define your all input parameters. So the perovskite materials, you can take hybrid, organic, inorganic materials, and you can make it supercell. You can repeat the structure on multiple times and create the heterostructure or supercell structures. And accordingly, it can perform different IR property, some absorption or some adsorption can be calculated. So vibrational property, phonon property calculation, the software can easily calculate. So at a single crystal, single molecule, up to the nanowire applications. So if you want to work on noble material study for spectroscopy prediction, analysis, silicon nanowire, so the chain can be calculated. We have the option, you can create the silicon nanowire structure by defining their radius, perturbation supercell structures, calculate the Raman intensity, Raman phase shift. So based on hybrid system, you can correctly calculate the different phase dominant for low frequency mode and high frequency mode. So we can calculate the Raman experimental density functional perturbation theory with different phase shift. So incoming photon polarization, outgoing photon polarization, and Raman incoming photon wavelength, temperature, optical damping, or the perturbation theory input parameter we can calculate. So photons light can also be do the studies. Even in the coming the DFT software rescue is also going to reinvent. So plus version with the in Python and Photon that is also in development for up to thousands of atom. You can simulate it. Python interface for ion dynamics, molecular dynamics, nudge elastic band, relaxation, band structure, density of state, molecular band unfolding, Spintronics, and plus version of quantum transport calculation, NANODCAL plus. So material development and NANODCAL plus both can be interlinked to each other, the enhanced versions. So we will discuss about the rescue code, but this is a new coming version, new product with a plus version for materials applications. So this is all about the basic software features. So in this Rescue Plus, you can work on different battery related applications. Like if you want to work on anode material, cathode material, the plus version will be there where you can use different applications. Just a minute. So the plus version that is under development, you can work on the battery related and different ion dynamics applications. Even if you want to work on graphene.
Hello.
Yes, please.
Excuse me. Sir, for a few seconds, your voice was cut.
Now is it audible?
Yeah. Now it is audible after you change the slide.
Okay. So let me continue the session. So basically the plus version with the Python that is also in development with machine learning so that you can work on different graphene layer with the different impurity with ion dynamics features. You can twist the layers and you can work on it with the machine learning applications. So either you are working on the plus version or common version, you have these features for battery related application, molecular dynamics, solid liquid interface. So with the only rescue and rescue plus, but we will cover basically the basic version. The plus version is under development, but I wanted to inform you about that tool as well. So this is all about a small presentation, what at material application. We will also have the session on device application. So participant, kindly be patient and we wait. We just request you to give your time so that you will understand the complete package, complete the different software that we are dealing with, and you will have a complete knowledge about that. So this is my information. If you have any questions, you can also ask your technical questions to me. Now let's start the demo session. So I want to show you the demo session. So all the participants, those who have not installed or those who have installed, those who have not installed, you can install it. There is no problem because the license will be valid for 2 months. So not to be in a hurry, you can download by after this training also, and you can perform your task after the training also. So we can help you in your downloading and installation if anyone is having the problems. So I want to tell you the software is downloaded in your C drive in Windows. Those who are using Windows. For Mac OS and Linux, there may be the same device studio folder in your directory. Now you have to go to the bin folder. Inside the C drive, device studio bin folder is there. So wherever you have installed your software, you can go
Hello?
to this particular folder. Yes, please.
Sir, excuse me, sir. Sir, one request from my side. I am from Telangana state. So today actually here is voting day, sir. Please, after completion of this session, recording video, please could you send?
Yes, we will send you, no problem.
Okay, thank you, sir.
Okay. Now you can see here, this is C drive, device studio and bin folder. So we have the application executable file. So I want to open this device studio. Device studio is basically a user interface that will help you to model the structures. So I just double click to open it. When I will double click, it will open this user interface. In the user interface, you can see there are two welcome window. Use the control below to create a new project or open an existing projects. So you can, since we are going to start from scratch, so we will create a new project. If we are already working in past, then you can also load your existing project as well. I can click on create new project and then click on OK button. Now I want to save the project path, project location. Let's suppose on desktop as an example, I want to save the project. So I want to give the name of my project, Nano Training. As an example, this is the name of my project. I can click on save button. It will save on my desktop folder, the project got saved. Now, whatever I will do, the manipulation, whatever material, whatever parameter I will create, that will load in the same project. So that's why you can see here, this is my user interface. This user interface will help you to create your material, to manipulate your material, to do the calculations, to do the visualization of your output. It is completely the single window. So now, first of all, I want to tell you about the file options. Okay. So in your people, those already working the installation completely, you can also go to the file option and then go to the new options. New option, there is option called import local, import online. So when you install the software, some material library also installed. Inbuilt materials also installs. So there is an option called import local. Local in the sense, in your system, in your computer, where my software is installed, that particular path, material library are stored. So I can click on the import local. And you can see here, I have reached to the same destinations in C drive, device studio, and inside that there is a material folder. So in the same directory, you will find couple of folders: 0-dimensional, 1-dimensional, 2-dimensional, 3-dimensional organic material. So the material library are categorized as per the dimensionals. So somebody want to work on 0-dimensional material, that is called molecular material. You can click on this 0D material, molecule, amorphous molecule, and crystalline molecules. So this is for amorphous polycrystalline molecule, amorphous molecule, polypropylene, polystyrene, polyethylene. Those who want to work on crystalline, these are some crystalline molecular materials are there. This is an inbuilt library of the molecule. Okay, so whatever molecule you are working on, if somebody working on, you can search here and then you can load it. Now, if I want to tell you, you can see here, this is option. AIMD.json, .as, .mol, .pdb. These are basically a third-party extension, file format extension. Many people are working on Gaussian or quantum espresso, so they can directly upload their CIF file, their material file in our this device studio interface. Instead of creating from scratch, your existing material can also upload in the software. So that's why the different extension is also possible, where you can upload the material here. Now, if you will go this back in the same material folder, you can go to the 1D material. That is called carbon nanotube. In the carbon nanotube, you can find different nanotube option is there. 5x5. Kral vector N and M value. This is called armchair, zigzag type. So different type of nanotube is already there as a 1D material. So whatever material you want to load it, you have to locate particular folder and materials are there. But you have to select it that which material you are working on. Similarly, the 2D materials are there. Some nobility material, arsenide, bismuth, black phosphorus, hexagonal boron nitride, even hexene, graphene is there. Let's say an example, we load this graphene. So I click on it and then I can load it, open it. It will load. I can click on this maximum option to maximize my screen. This is my user interface. This user interface, I can hold the right mouse button and move the cursor. To move the crystal structure, I can hold and move it. For moving it, I can hold the right button and move it, the cursor, to visualize from every angle. Now this is one material which I imported from my library. Apart from that, if you will go again on the file option, import local option, then you can go to this 2D material. Sorry, this material. You can go to this material, 3D material folder, conductor, insulator, layer material, magnetic material, oxide material, semiconductor material. So these materials, you can find it in the respective folders. So whatever material you are working on, there are a couple of existing material library are there. So if you are working on MOS2, then you can also load another material, MOS2, and click on open it. These two material I have loaded in my dashboards. Now we will do many manipulation in the structures. Okay. This is the one procedure which I told you, where how you can load the material from our own library, from the software database. Software database consists of lot of materials. Maybe you can find in the existing library. If the material is not present, as an example, let's assume the material is not available in the library, then the second option is called import online. There are a couple of online library of the materials are there. So you can click on import online. Once you click on import online, you can find this. Let's suppose you want to search boron nitride. So I type this formula. It is case sensitive. So that's why I type boron nitride, and click on search button. Now once I click on search button, you can find these are the multiple combination of boron nitride is available. So this is basically a third-party integration through the API access. It will fetch the material from third-party database. So those material not exist in the library. This is one of the another option where you can import the material from other interface options. So you can click on here any material. These are different formula and space group. So whatever the material you are working on it, you can scroll down and find a lot of combinations. These all space group and their respective structures. So structure will display in this black screen, and the coordinate point, the atomic coordinate point, atomic length, Brevis lattice parameters, that will display here. You can see this is generated by using PY mat generator. the cell length A equal to 10 point something, B equal to 10.8 something, C equal to 11.0 something, alpha equal to 91, beta equal to 88, gamma equal to 91. So alpha, beta, gamma, ABC value of that particular structure, that particular material which you have selected, that will display here. So I can scroll down and I can check the chemical formula, volume, and some unit cell, their coordinate point of each atoms. The number of atoms, their coordinate points will be displayed here. If you will select only single boron nitride, you can select this is single structure and there is one boron and one nitride. So as an example, the new material, how you can add. If you want to search aluminum arsenide as an example, I mention aluminum arsenide and click on search. Now all combination related to aluminum arsenide is displayed. This is aluminum arsenide materials. So aluminum arsenide, these are all combination of aluminum arsenide with different space group. This is space group information and this is a formula. And this is its ABC value, alpha, beta, gamma value and their coordinate points. Whatever coordinate point you can visualize. Okay. So once you can click on it, then you can click on add button. Once you will click on add, it will add in the dashboards. So this is a two process which I have shown to you. One is called you can import the material from our library. Second option, if the material is not present in our own database, our own software library, then you can import from third-party database. So this is called import online from third-party software material database. Now, the next option is called, the next option is called new option. New device, create crystal and molecule. So the window is single window where material simulation can be performed and device calculations can be performed. So that's why we have to discuss one by one and will clarify all your doubts in this program. So if you want to start to create the crystal, you can click on this crystal and this window will pop up. This window will help you to create the structure from scratch. Let's say example, the online material is also not available. In database, it is also not available. Then this is the third options where you can select the space group type. That's why the 1P1, 2P1, 3P2. Participants can type your questions in the chat box because I cannot read your message I cannot read your message here. So basically there may be some API issue. Those who are having problem with some API issue in your license. So we can look into that. Those who are facing some problem in your current systems. So here you can see these are different type of space group options are there. According to the space group, the type of lattice will be selected. So I have selected as an example orthorhombic body central from this space group. If you will select different other, accordingly the tetragonal or different type hexagonal, rhombohedral, biclinic, triclinic, cubic simple, and the ABC value or alpha, beta, gamma, that will enable accordingly. So let's suppose this is a simple cubic structure. We have to define the P1, P2, and P3 that are in fractional coordinate points. So click on this plus sign. You can find this is the cube is there. In the cube, in the lattice, the position of the atom. Either you can put it at the center of the position or 1/4 of the positions. So if you want to put it at center or 1/4, you can select here and click on preview. Now this is at the position it will display. The carbon atom position it will display. If you will make it 0, then by default it is a carbon atom. By default it is a carbon atom element is taken. But if you want to take different other element, the periodic table will open. Once you click on the element, this is called element. Click on this element, by default carbon, you can click on the carbon. Let's suppose you want to make NaCl. You can select this sodium, and next you can select the Cl, chlorine. So you can select Cl here, and you can make NaCl crystal. As an example, like that. So this is basically a procedure that how we can create the structure from here. And you can add more number of parameters. You can add according to your need. You can add these things and you can visualize. The structure can be created in this particular crystal builder. It is basically a crystal builder which can help you to build your structure so that you can visualize it. So crystal builder is there. This builder will help you to create the structures as per your needs by defining their ABC value, alpha, beta, gamma value. You can create like that. And then you can see the symmetry operation, x by z, minus x minus by z, minus x by minus z, the space group, symmetry information, preview. And once you accurately build this structure, then we can click on build. How different structure can be built? We have a separate video, separate things will be there. But you have to suggest your coordinate points. Once the coordinate point you are defining accurately, the crystal will be accurately built. But you should have some input. The software can perform their operations, but the input need to be given by the users. So that's why the license will provide to you. You can do at your ends. You can perform in your computer. Later this works out. Initially, let it concentrate about the features, about the parameters, about the applications, that what different kind of nanostructure material the software can perform and can do the calculations. Now, this is the third option where I have suggested how to create the crystal. So by clicking on this new option and crystal option, you can create your new crystal. You can similarly, if you want to create a molecule, this is a molecular builder. If you want to create the device structure, this is a device structure. For a molecule, you have to click on this molecule option. This is one device studio molecular builder. You can click on this add atom. And this is element mode viewer. You can choose the element, whatever type of element you want to choose. You can select, it will display the fragment. The fragment will be displayed. You can see the molybdenum different fragmentation are there in this left side. You can visualize this left side screen, the fragmentation according to the atom. Based on atom, different molecular structures are there. You can see these molecular structures. And then you can click on this back side. The structure will be ready. Number of atom, bond radius, and their bond tagging. If you want to click on this, this is basically to modify the angle, bond, dihedral. You can add the hydrogens. You can import different molecule also, and then you can modify it. So this is basically for molecular. You can apply data and the molecule will be created like that. We have another option to create a complex molecule. This is for, you can go to the builder. There is another option to build the structure that is called build button. Build button will be there on top of the screen. And there will be a molecule 2D option. Once you click on molecule 2D, This is a molecular builder. In the molecular builder, you can build your own molecular structures. How? You can click on this option. Let's suppose you want to make this benzene type. You can click here. You can add different element. Similarly, you can add, these are the multiple options are there. You can take the chain of the molecule. You can create your own molecular structure from here. And you can explore these all features. These are different combinations are there. Once you can create your own desired molecular. We can go into the detail in the coming session, but this is just for your information that how you can create and apply the data and molecule can be created. So we have a crystal builder, molecular builder, device builder, and as well as the import option from the local library, from online library. Online it can also fetch, locally it can also fetch. And fourth option, that is called third-party database. If you have the HZW file, XYZ extension, CIF CIF file, crystallographic information CIF file, XSD file, postcar file, contcar file, FCF.import, relax.json, these all file format you already have, you can upload it. This is another options. So there are 4 options I have suggested to load your material in our dashboard. On the dashboard onboarding process, this is the onboarding of the material process. So how we have used different material and loaded in our dashboards. Now this is a user interface, this whole screen, that is called graphical user interface. This user interface will help you a lot to manipulate your structures, to create the desired shape, to create your own atomic structures, lattice parameters, some different coordinates and doping, defect, transistors, anode, diode, for everything. It will help you a lot. Now, these are different materials that I have loaded. You can see this is Nano training is a complete folder name. Now you can see this is Nano training is a complete project name that I have taken in the beginning, and these are all material: graphene, MOS2, aluminum arsenide, crystal, molecule, and this molecule one. This is basically this particular area. This particular location is specified for input file and output file. These all are input file. And once the simulation will be performed, then output will also generate in the same region. This particular region is decided. This is allotted for the input file and output file. On bottom of that, there is a property tab, property toolbar. In the property toolbar, there is a vector A, vector B, vector C, total number of atoms, total area of lattice. So this is basically displaying the number of atoms in your selected crystal. Nowadays you can see the graphene crystal is selected. In this particular crystal, how many atoms are there? What will be the lattice of this particular crystal? And what will be the ABC vector coordinate points? So vector coordinate point, total number of atoms, total area of the unit cell, that will display in this property tab in this left of the screen. So left of the screen, XYZ contact information, XYZ vectors, total number of atoms and lattice. If we select this MOS2, you can see the total number of atoms are now become 9. If I will select this graphene, the total of atom in this particular graphene, it is showing 2. But this MOS2 in this particular unit cell, there are 9 atoms are there. That's why it is displaying 159 angstrom is the lattice of this total lattice of this unit cell. Similarly, different lattice, the length of the lattice. If I will click on here, the number of atom, total area of the lattice will be displayed. So this is a property tab bar, which will display the atom number, lattice, and ABC vector coordinate points. And bottom space, bottom area, that is basically a calculation, job calculation bar, job manager. So bill calculation will run on bottom of the page. In this particular screen, the bottom white screen is there where the simulation will run it. And black screen is there. In the black screen, our all project, material, device that will display for the visualization purpose. I want to describe you about the user interface, then we'll go in deeper insights about the product one by one. Just you have to keep patience, keep concentration, keep learning on the software so that you will have more deeper insight about the product. Now you can see on the top toolbar, there are a couple of options are there. These couple of options, there will be a defect creation options, rotation, zoom, different angle visualizers, delete, move, rotation, stretch, measurement icons, and convert options, and fit to screens. So these options will help you to manipulate your structure, to make proper arrangement, to reduce the mismatching, or to measure the distance between two angle, and many more things. We will go one by one in each details. One by one, we will discuss each of the features of the product. Okay, so let it discuss about it. So this is single graphene crystal, which I have taken it. Similarly, if I want to take any other material, as an example, I can go to the simple import local, 3D material, semiconductor, and let's take simple material that is called silicon and try to perform properties. So this is single silicon crystal. I click on the particular atom. This is silicon crystal, X by Z. Coordinate points are there. If I will click on this particular atom, silicon and X by Z information are there. So any atom, I will click on it, it will display the X by Z. If I will click on this atom, it will display this atom information. And if I will not select any atom, the whole symmetry information of this crystal unit cell will display. Now this is all about it. Now I want to perform the calculations. So to run the job, to run the simulation, simply click on the simulator. Now you can see we have a rescue, we have a NANODCAL. NANODCAL will be for device simulation, quantum transport calculation, transistor simulation, and other options. As you can see the transistors. Initially, let it perform the FCF calculation, material applications. So I select the FCF calculations, self-consistent field calculations. In the self-consistent field, once I will select it, this is FCF, calculation for crystal, because we have selected the crystal and it is the crystal here. Now smearing sigma, the theoretical things you have to learn from your theory books, papers, thesis and all those things. But I want to tell you how you can define different parameters and you can do the manipulations in the structure. Resolutions, this is a two method. As in the presentation, I show you two methods, real space, electronic structure calculator, and linear combination of atomic orbital. Real space electronic structure calculator, real space linear combination of atomic orbital, LCAO, and real space. There are two methods. Real space is like plane wave, and this is exchange correlation functions. LDA-PW, GGA-PBE, LDA-PZ, LDA-BWN, PBE-SOL, XPBE, and different other functions are there. Hybrid GGA, HSE06, V3 lib, Meta GGA, and these are Meta GGA and GGA, LDA, and hybrid GGA. So these all functions are there. These functionals will help you to accurately predict the band gap of your semiconductor materials. Next option is called iteration control, charge density plot, total energy. This is basically an iteration control method. It will calculate the charge density and total energy calculation. Maximum SCF calculation steps up to 200 iterations. It will run the calculations with a mixed Poulet method, mixed density matrix method, potential maximum variables, and maximum trees. Eigensolvers are there, maximum eigensolver iteration, and basis sets. This is for basis sets where you can use the LDA plus Hubbard U. Double zeta polarized is there, single zeta polarized is there, even user defined basis sets. If I click on this user defined, so single zeta polarized, double zeta polarized, single zeta single polarized, double zeta double polarized, or even this different basis sets are included. These are different basis sets are given in our library. For each material, you can use different basis sets, and then you can perform the calculation. So user-defined basis sets are possible. We have the library of basis sets. You can choose according to your material in your atomic structures, and then you can perform the calculations. And then for spin type, if you want to perform the spin without a spin, that is also possible. If you want to perform the collinear spin, you can click on collinear spin, define the magnetic movement. If you want to perform the general spin, this is for general spin, magnetic movement, spin orbit coupling, spin orbit interaction, that is also possible. Let us simulate without spin and click on generate file options. So I click on generate file option. Now here you can see rescue, the silicon folder is created, rescue crystal is created, scf.input file and atom.input file. All the input file and output file will display in this particular regions. So if you want to visualize the code, the script that is generated with the software, you can simply right click and click on open with. In the open with option, you can see there is info calculation type. Info calculation type, self-consistent, field option, symmetry space information, whatever we have given in the user interface, the code will automatically generate. You have no need to worry about the coding that is auto-generated from the user interface. But I wanted to tell you where the code will generate or it will execute. So this is automatically generated script from the user interface. If you want to check the atomic coordinate position, you can right click on atom and click on open with. This is the coordinate point silicon with their XYZ coordinate point informations. Now to run the calculation, you have to right click and click on run button. Once you will right click and click on run button, you will find this window. You will be able to run on serial calculations. So I will right click and click on run button because it is a trial versions only just given to explore the capability. That's why it will run the calculation on serial only. Now here you can see in the bottom of the page, the calculation is running. Simulation is running the script. It is running the program. So it is showing the material name, the script where we have created the project on our desktop with this nano and minus training folder. Inside that there is a file called scf.input. So we are running this calculation. It is running here. We can stop the calculation. If I can click here, stop, it will stop it. If I will want to see the data calculation window, I can recalculate or I can also delete it. So simulation will be running in the background. Once it is completed, the log file will generate. Sorry. So let's wait for 2 minutes. Let it finish the calculation. Simulation is going on. You can see the rescue.out file is generated. So this is a calculation out file. This is the calculation out file which is generated. So the simulation is running it. And you can click here to see the calculation status. This is silicon job status. So this is calculation. Now you can see this finishing self-consistent calculation at this particular date and this particular time. So at what time the calculation is started, it will display the calculation time is started and the calculation time it was finished, and how much time it will took, that will also take in. So you can see all the calculation information. You can see the calculation is completed, status, the simulation is done. And this is all input information of the log file. So it has generated some source file, some basis sets file, some real space method, some vector coordinate point, resolution type, boundary type, differentiation methods, number of atom, number of electron, spin type degenerated, and their K points, K point grade, reduce K points, sampling methods, mixing algorithm, whatever as an input we have defined, it has done the calculation and will predict some output. That's why you can see this is all theoretical DFT calculation things. These are different iterations which perform in 10 steps. The calculation iteration were performed for 10 steps. So it will compute non-local force, correlation force, local pseudo-potential force. So whatever it is time, that will show here how much time were taken in self-consistent, in force calculation, and in saving the time. Saving the result, the total time will display. Now I have run the calculation by using the rescue simulator. So I went to the simulator, and rescue and SCF. I perform it. We can also do the relaxation. If you want to do the relax your structure, the relaxation is also possible. Let's go to the analysis part. So I go to this analysis options. Now here in the rescue, since rescue is for material applications, so you can see the band structure and density of states, molecular population and potentials. So these are options are there to calculate the material property. Now in the band structure, you can see the symmetry K point information is there. You can click on the path. This is U, X, G, X, W, K, G, L. This is basically a general point. It is given as a general. But in your particular material, the Billion Jones root point may be different. But you can add these points, you can delete the points. That's why the new position you can add, you can delete the existing position, you can move the Billion Jones point up or down according to your materials. That's why the high K symmetry points, Billion Jones for band structure is default, something is there, but user can change according to their needs. Number of K points are there, total number of K points will be the 600, but default number of K points is 50. Empty band structure, partial wave function calculated, energy end of band, direct K point value, partial bit, band structures. Similarly, the density of state parameters, sampling point, energy interval, K point sampling, smearing, projected density of state and local density of states. And this is for potential, van der Waals potential, effective potential, neutral atomic potential, exchange correlation potentials. Different type of potential can be calculated. Now I can click on the generate file option. Once I click on generate file option, you can see couple of input file is generated. Earlier only there was scf.input file and atom.input file. I can right click on this band structure and click on band structure dot input file to run button. Right click and click on play button. Now the calculation is started, that you can see the simulation is running. The job is running here. So yes, definitely the participants can edit the material. You can manipulate the structures. There will be a lot of things which you can do. If you want to manipulate the structure, that is possible. Maxine is also there. Like graphene, I already selected. That is option is there. Even if many material is not present from the open source library or from database or from existing third-party option, you can upload it. So multiple options are there. So graphene is there, MOS2 is there, WSE2 is there. Molecule can be like you can manipulate, modify. You can crystal, you can modify. The devices you can modify. It is user defined. It is customized software. So user can change according to his own requirements. So that's why you can do different research according to your needs. Now you can see the band structure calculation is going on. Now in the meantime, band structure is running it. I want to run the density of states. Now since it is a trial version, basically we have given the trial period. So the software is commercial license version software. You have to purchase it. Your institute have to purchase it. The trial version is just to given you to check the capability of the software. See how the software can be beneficial or value for your money, for your institutions. So you can explore it, you can effectively use it, and the parallel simulation is possible, but it will be on the purchase license version tool. I can click on run button and my density of state calculation in the queue. So automatically it will execute once the band structure is finished. Similarly, I will click on this potential, right click on the potential and click on run button. It will also in the queue. So we can put it our all input file in the queue and we can go anywhere, and whenever we will come back, then we can see our output or finish the calculations. The trial version is the given this 2 months is just to explore it, it's just to see it, how the software are beneficial. So but the software is commercial. It is a license version tool which need to be purchased by your institutions. So if you will be technically satisfied the capability, then you will have to plan. If you have not satisfied, may not be requirement, then it is a secondary things. But first, the main goal is just to explore the software in deeply, so that you have an idea that how the existing software are not as much as feature as exist in this softwares. So simulation is running, other are in queue. We can also terminate the job. We can stop the job, cancel the job at any time by clicking on this cancel. Now you can see, I can hide this. You can see here, it is hide. If I want to visualize it, I can collect again and see the live band structure calculations. I can hide it. Now this is top toolbar. This toolbar will help you a lot for different kind of modification, visualization in your structures. So 90% the software is having independent. Sometimes 5% maybe the software will generate the output file in MATLAB format. So if those who having MATLAB tool installed in their computer, that will be a well and good. If not installed, then you can also try to install it from your login ID. Maybe institute already have some MATLAB software. Even if you not have the commercial purchase license in your institutions, then you can also have the crack version of MATLAB is also available. So MATLAB is also required. So in this 5 days training program, I suggest the participants should also install the MATLAB software as well. That will also help you a lot. So the calculation time basically dependent on the parallel and number of cores and the iterations, number of atoms, as well as the license type. Software support on GPU also for faster calculations. And you can see this is a builder. This builder, there are a lot of options are there. These options will help you to create your structures, to repeat your structure, to modify your structure, to add the atom, to defect the atom, to add the doping. So this builder and toolbar, both will help you to create the structures quickly. Now you can see the band structure calculation is finished and density of state calculation is running. Then potential calculation will be started. So one by one, the software is executing. In the meantime, if you want to do the analysis, then you can do the band structure one, rescue one, and go to the analysis plot. In our desktop, we have created this project. So I can go to the rescue analysis plot, and on the desktop part, I can click on this desktop. Nano training is the folder where all things we were performing from the scratch. We were doing it. Rescue crystal, results folder, and band structures. This is a text data which is generated by the software. I click on open button. And now you can see here the band structure for this silicon is calculated. So this is the way where you can calculate the band structure. As a random parameter, I took it. Whatever different basis sets, exchange correlation functions you want to perform, you can take according to your needs. But this is the procedures that I wanted to tell you. So already extracted data is given in our directory. If you want to export again, there is an option called export. You can export this graph in the form of image, PNG, JPG, BMP, PDF, TIFF, EPS. Text format, the data is already extracted. That's why we have loaded the data in text format from the library. Now the density of states also finished the calculation. Potential also finished the calculations. So I go there, simulator, rescue, and go to the analysis plot. And here I can select the density of state and click on open. Now this is density of state for the single crystal. I can zoom particular regions and it will visualize like that. So you can zoom it. It will show the graph for density of states. So we have to plot the data as like that so that you can easily calculate different analysis. And this is for Jones. This is without any spin effect. If you want to add the spin, collinear, general spin orbit interaction, that is also possible. Now let me also import the potential curve. So I go to the rescue analysis plot and click on this potential, VDH, neutral atomic exchange correlation potentials. So I click on this VDH or neutral atomic and click on OK. Once I click on OK, this is neutral atomic potential, crystal structure. I can click on this 2D graph. This is two-dimensional neutral atomic potential. So with the spin up is equal to spin down, average along X, average along Y, along Z, and this is plane display. And if you want to see the stereoscopic display analysis, you can see this stereoscopic display of this density of state. This is one-dimensional plots. So 1D, 2D, and 3D. This is two-dimensional, this is three-dimensional, and this is one-dimensional. So one-dimensional, two-dimensional, and three-dimensionals. All results are possible. Either you can see in XY view, XZ view, YZ view, YX view, ZX view. These are some different views. So whatever the type of view in 3D, you can see the isosurface also. This is isosurface, can also be iso value. If you want to see this iso value is also there. This is for iso value. You can also check with iso values respective. So not only 2D, 1D, 2D, and 3D, simple and planar display. These are different analysis. So 1D in X by XZ, YZ, you can plot it. So this is a way where I took the simple single crystal and told you the procedure. What is the procedure? Whenever you will use the software in your computer, the same procedure need to be followed. But it is a basically ongoing process. It is not a single process where you can do by a few days. It requires some time to learn the capability. You have to become familiar with that. That's why the license is for 2 months. It is not for 1 week or 2 weeks, because it takes time. But we learn it, we will support you, we will help you. Now this is single crystal which I have tried to simulate it by using this rescue softwares. Okay. Now the same thing, if you want to simulate the material from rescue, this NANODCAL. This is the NANODCAL, which can also do the material simulation as well as the device simulation and transistor simulation. So material, devices, transistors. Rescue can also perform the material calculations. So I hope the participants are not boring. You are enjoying the session, right? Now, this is single crystal which we have taken it. Now, if you want to perform, yes, please. Anybody wants to ask something?
Yes, so the density of states like silicon density of state is little different than that.
Yeah, basically all the things are dependent on the input. I took simple material and taken the default parameter. But whenever you define the exact parameters, you will get the same density of state output.
Okay.
Now, if you want to redefine this crystal, this is single crystal, you want to redefine its position. You redefine in the sense, you want to repeat the same crystal in X, Y, Z direction. So you can click on this crystal option, redefine crystal. This window will pop up where A, B, C. If you want to repeat vertically in B direction, then you can click on, let's suppose 5 times you want to repeat. This is B 5 times. Click on preview. The vertical times the same structure is repeated 5 times. So you can see here, this is 5 times we have repeated in the same direction. Vertical direction, this B. If you want to repeat C direction, then you can define this C times, let's suppose 3 times. Then 3 times the same crystal is there. same layer is there. If you want to define this A, let's suppose 6 times. A is called G directions. So this is called 3 layers is created. 3 parallel lines, parallel structures are created. If you want to take only single layer, you can change it C from 3 to 1 and click on this only single layer. The structure is redefined. We have defined the same single crystal to new positions and click on build button. Now you can see here, this is only one side we can visualize. If you want to visualize on XY view, XZ view, YZ view, YX view, ZX view. So if you want to see XY view, click on XY. This is a XY view. If you want to zoom it, this is a zoom button. You can visualize and zoom in properly. So this is XY view. This is XZ view. This is YZ view. This is YX view. And this is ZX view. So any angle, whatever angle you want to view or you want to rotate, you can visualize your lattice structures. So these are all silicon materials. How? If I click here, this is select option. I click on atom. This is carbon element. This is basically a graphene carbon element. All are carbon elements. So you can simulate this carbon nanostructures also without any dopant, without any adding the defect. So without any adding the defect. So yes, participants, you will also get the manual, tutorial, project, everything we will share it to you. So if you want to simulate this single layer, this structure, that is also possible. For that purpose, you have to do the same thing. Go to the simulator, go to the rescue and FCF calculations. And here you have to set all those parameters, smearing, resolution, real space, and linear combination of atomic orbital with von Neumann, sampling points, iteration control, basis sets, spin type, spin orbit couplings, you can generate here. For this redefined crystal, you can see there are around 60 atoms. In this unit cell, graphene crystal, graphene nanostructure, there are around 60 atoms, 1055 lattice area. And I have clicked on this generate file. So the scf.input file and atom coordinate point information input file is generated. So 2 input file is generated. scf.input file. Earlier I have done for silicon. This time we are doing for graphene. So atom scf input file, right click and click on open with. You can check the background code generated from the software. Similarly, the coordinate point of atom, right click and click on open with. These are all coordinate points. These are all coordinate points. Now to run the calculation, we have to do the same thing. We have to run the calculation, click on run button and click on run. Simulation will start here and it will take time. Since it is a first day, okay, so we are basically going one by one, slowly, so that participants will get clear picture in their mind that what software can do, what type of features are exist, what types of things are can be done. It is a 5 days program. So be patient, be learn, be easier, and you can also perform in your computer. If you will face some problem, we will try to help you as well. You can see the calculation as it started. So what I have did from the scratch, basically I have this graphene single crystal, I redefined it. I took this graphene single unit cell, this one, and then I went to the build option and click on redefine crystal. And then I define this A, B, and C. I change its position and the crystal were created, which we can look like this one. This is the process which I have followed to increase the number of atom and the calculation which I have run it by right clicking and click on run button and then run the program. So the program was executed, rescue log.out file is generated. So you can see the simulation is running, the calculated completed simulation and running it. We can take the action to stop the calculation, and it is the inspect simulation data in real time, where you can see this, the calculation log which is running here. This is the log calculation. Log var calculation which is running, that is showing display here. Now you can see these are top many other options. If you want to measure the distance in between any two atoms. So left side you can see this is a distance measurement tool. You can click on the distance. You can click on one atom and click on another atom. These two atoms from center to center, 2.842 angstrom. This is the distance from one atom to second atom. Similarly, if you want to measure the angle, you can click on the third atom. And next option is called this angle measurement. Click on it, one atom, two atom, and three atom. This is the angle measurement, 60 degree. So angle can be measured. This is distance from this atom to this atom, and these three atoms, the distance is measured as well. This is distance measurement and angle measurement. So right side, you can see there are two options, distance measurement, angle measurement, as well as dihedral vector measurement. So this is a dihedral in the plane measurement. Laptop, let's suppose in the laptop there is a vertical, there is a horizontal plane. Vertical plane and horizontal plane. How much is the plane to plane angle? Let's suppose in my angle, there is one screen is like that and another screen is like that. So from that 90 degree angle is there. So that dihedral can be measurement, AB vector can be measurements. So vector measurement, let's suppose you want to measure the channel length. So the channel length can also be measured. Lot of other options are there. These all options will be discussed also one by one so that you will have clear idea. It is single layer structures where we are trying to simulate. So from the scratch, I have told you how to import the material from local database, from third-party database, from your online material database, and how to create from scratch. Device part we will cover up in the coming next session. But here you can see a lot of other options are there. So these are input file, output file window. If you will right click on the project, you can click on open containing folder. In this particular project folder, what other parameters contains. So if you will click on it, it will load or display you the information of that particular crystal. So this is a crystal with their whatever the result file, if it is generating, it will display here. Since the result is not generated, simulation is going on. That's why it is showing the empty folder of result window. But all other folder, SCF input file, atom.xyz file, rescue log.out file, that has generated. But if you want to see for silicon crystal, I can go to the silicon crystal, double zeta polarized basis sets, rescue crystal, and these are results: band structure data, density of state data, potential data. This is the data which is calculated from the softwares. The previous example which I have simulated. So the data will contains in that particular project folder which we have generated. But as you know, the simulation is 60 atoms are there, and we are running the job in serial calculations. That's why the simulation is taking time. It depends on your computer, your license, your processors, and iteration, number of atoms. Many factors are there. It is not a single factor in terms of simulation speed. Multiple factors which decide how much simulation time will be taken by the software. So I hope participants have got some basic idea what this software at material level only. We'll go about more deeper insight about the different application. But for your reference, those who were asking about the tutorials and manual, I want to give you the information about the documentation and tutorials. So just a minute. You can type in your chat box, this YouTube search box, Impulse Technology, Innovate Your Research. This is our YouTube channel. In the YouTube channel, we regularly do some different kind of this hands-on training. Whatever different kind of material we do the simulation, we prepare the video and post in our YouTube channels. So this is our YouTube channel by the name of Impulse Technology, Innovate Your Research. You can also search in your YouTube channel and you will find this information. This is our channel on the YouTube available. You can go to the video section and there are a lot of videos we have prepared on different applications. So you can visit our YouTube where different experimental equipments, simulation softwares, and many things we do upload in our channel so that you will have some clear idea like how to build the crystals and many more things will be there. So this is our channel where we have prepared already a video. License is already given to the participants. They can work in their software and use it properly. And then we will keep continue with you. We will keep in touch with you so that whenever the problem arises, then we can help you. You can go to the playlist option. In the playlist, we have a multiple software. As I have wanted to show you, we have a quantum TCAD software, material simulation, device simulation, transistor simulation, large area PV module, probe station for characterization. So we have a multiple playlist for that. Since today we have discussing about rescue software. So I can go to this view playlist option. And these are all rescue videos. These are rescue video that uploaded in our channel. So you can also watch it later on. You can watch these videos and you can also make hands-on practice on different applications. This is one video information to the participants. Second one is called this Impulse Technology website is there. In the website, you can find different product. You can go to this Nano Academic and click on Rescue Software. These are some key features about the software, different things. And these are some video link are there. Same video link which is available on our YouTube, it is available here as well. Now, theoretical things, if you want to know the theoretical background information on what algorithm, what equations the software were implemented, then you can visit this nanoacademic.com. This is a main parent company, Canadian website, design tool for next generation materials. You can visit nanoacademic.com and scroll down till the bottom of the page and go to this documentation, rescue, NANODCAL, rescue plus, NANODCAL plus, and go to the documentation page and go to this rescue. Since the software supports on MATLAB as well, it works on MATLAB application, then you can see here the introduction about the rescue package, on what basis, on what parameter the DFT were implemented, that information, as well as the installation procedure. This is installation procedure in MATLAB that is explained, and some tutorial. These are some bulk silicon tutorial, graphene PDOS. These tutorials are basically written in MATLAB, but videos are available which is given on the device studio. These are some getting started video, how you will get it started with the software, bend and folding, Berry curvature, boundary conditions, perturbation theory, ion clamp, phonon calculation, electron phonon, Raman spectrum, nonlinear optical susceptibility, molecular populations. So this is all information about the theoretical things. So you can visit these channel, these websites, and you will find the information about the theory part. So you can visit here and you will get to know the information about this. So whatever type of pseudo potential, it is mentioned here, the type of pseudo potential, neutral atomic potential, different element, database of pseudo potential, simulation parameter, input file, calculation type, bulk silicon examples, and many different things are there. So those who are very familiar with MATLAB, you can also use the software in MATLAB without device studio. These are all tutorials. The code which is generated, it will display here. Even parallel calculation is also possible. MPI parallel calculation, that is also possible with the software. And you can calculate the total energy per atom. If till now any participants have any questions, you can raise your queries till now, then we can go for next things. So if those participants want to use their own CIF file, yes, definitely you can also upload your own CIF file. If I will, let me search one CIF file. Let's suppose you can see here these CIF file are given in my computer. So I can, let's paste it on desktop and would like to show you how to upload it. So this is there, you can see gallium arsenide and MOH2 primitive cell. So I would like to upload here. So let me remove this MOH2 so that it will not get confused. That MOH2 I have removed it. Now I want to upload the CIF file. For that, what I will do, I will go to the file option, go to the import option and import local option. And once I will click on import local, I will browse my file where my file is present. My file I pasted on desktop. So I select this desktop gallium arsenide primitive CIF file and click on open. Now it will load. You can see here, this is gallium and this is arsenide. Left side you can see here the single similar type of crystal. This is gallium. One element is called gallium. How do I know? I click on the select option and click on this option. This is gallium and this is arsenide. So I have loaded this CIF file. Let's take another example. I click on file option, click on import local option. And again, I go to the desktop where my MOH2 file is present, CIF file. I select it and click on open. Now this is MOH2 file that I have loaded. That was present in the form of CIF. If I want to delete any atom, I can simply hold the left mouse and draw the rectangle. Hold the left mouse and draw the rectangle and press this delete button. Either you can press on the keyboard or you can press in this delete button. It will delete that particular MOH2 crystal because there were two MOH2 crystal in the unit cell. So one crystal I have deleted. I can click on this home button to become home in the main screen. And to make it center, I can click on the center button. I can make it center along A axis, along B axis, along C axis. So any axis, if my atom are not in center of that, we can make it center by single click. We can click on this one, and it will make the position of my disbalanced atom to the center of the position of unit cell. Now that rescue, you can see here the calculation for this graphene, it is finished. The graphene calculation has been finished for 60 atom. And for that purpose, we can go to the simulator, go to the analysis one. Similarly, we can plot the density of state, molecular population, band structure, potential, and we can see the projected density of state and click on generate file. Now we have to run all the input file of my analysis one. So I'm running it, all input file, and bottom of the page, you can see the calculation is running. It is running projected density of states, then band structure, then potential, then molecular populations. One by one, it will execute it. We can see the real-time analysis from this. Whatever it is generated, that will display here. to create the defect, we can do, if you want to make same kind of graphene, let's suppose I can right click and click on copy, and then this is a new similar graphene structure will be created with a different name. So this is another same graphene structure which I have created. If you want to create the defect, you can simply click the particular atom and press the delete button. Once you press the delete button, the atom will delete it. This is the deleted atom. So the defect can be created like that. You can make it undo. If anything happen by mistake, you can make it undo, and then it will go to the back positions. If you want to replace the atom, I have selected this particular atom or any atom. Let's suppose as an example, this atom, yellow color, it is selected. Click on this option, replace atom. If you will click on replace atom, different element will be displayed from the periodic table. Whatever type of doping you want to do, N type or P type, select particular dopant type and click on OK. It will add that dopant. So the color of the atom is also changed so that you can identify. If I click on this atom, it is showing the magnesium atoms. The projected density of state, its calculation is completed. If you want to see the analysis, I can go to the rescue analysis. Sorry, I can go to the simulator, rescue, and analysis plot. Now that was graphene redefined crystal, rescue crystal, and density of states. Click on open. Now this is density of state for SPDF projected. So total SPDF, we can see the projected density of state like that. Minimum and maximum value. We can define the value control, word control, and this is like export button. You can export your data from here. So PNG, JPG, BMP, PDF, TIFF, EPS, these format data can be exported. The software is very broad. There are so many type of structures, so many type of applications. You can work on it. So that's why we have a full time 5 days program where you will learn many things. Sorry. Left side window is totally for input file and output file. This project property window is basically for information about the selected crystal. Bottom bar is basically for job manager for calculation of the job. This is a builder where a lot of features are there that will help you to build your structure. And this is simulator. We will cover up NANODCAL also for device calculation in coming period of time, and rescue also with perturbation theory. We can also do the DFPT calculations. So relaxation is also possible. You can relax your structures. That is possible. If you will click on relax, you can relax by using quasi-Newton method, steepization method, conjugated gradient methods. Based on these two methods, you can relax your structures. If you want to perform the perturbation theory, as I told in the presentation session, the rescue not only work on density functional theory, it works on density functional as well as density functional perturbation theory. So if I click on perturbation, these are some basic features. In this basic feature, you can see the phonon band structure, phonon density of states, phonon band structure and density of states, optical properties, Raman properties. In that, you will calculate the refractive index, Raman intensity, energy loss, IR intensity, susceptibility, dielectric constants, and many more properties will be inside of that. And for phonon, this is for phonon structures. If you want to go for optical analysis, this is for optical, electrical field direction and damping factors. So based on real space method, it will calculate the parameters. For Raman property calculation, Raman intensity, Raman phase shift, damping factor, Q-point Cartesians, incoming photon polarization, outcome photon polarization, incoming photon wavelength, and temperature dependent. So this is for Raman spectrum, Raman polarization property calculations. This will not only perform for only DFT, for only material calculations. It will perform the phonon as well, optical as well, and Raman as well. This is brief idea about the software, that what software application is at material application. To run the calculation for Raman or optical, you have to select this Raman. If you want to perform phonon, select the phonon first. Let me, because number of atoms are 60 in this, so it may take some time. So better I can take a small molecule, a small single crystal. Let's suppose you want to simulate this MOS2. And for that, I can go to the simulator, rescue, DFPT, phonon calculations, and click on generate file. It will generate the required input file, FCF dielectric.input file, phonon.input file, phonon band structure.input file, and atom.xyz. I will right click and click on run button and click on run. Similarly, I can right click on dielectric. If you want to visualize the background code, DFPT method, mixing tolerance, pi, rho, you can also visualize. And right click and click on run button and run the program. Right click and click on run button and run it. So you can right click and click on the all the executable file of the input file. You can run it so that it will execute. So it may take some time as you already know. The previous band structure calculation is going on. But the procedure is same. The license is also given to you. You can also perform in your system for different material, for different applications. I hope you will get some expectations. But I want to inform you the software is given just to educate you, just to inform you about different capabilities. So now I request to the participants, you can also ask your questions, because nowadays I think more than 2 hours is done. So if you will ask your questions, then we can have next coming session, which we will discuss based on your particular application. We will try to cover up. But I want to say you, since the software license is also given, so you cannot expect that we can do your research paper. We cannot do your research. We can show you, yes, it is possible in the software. That possibility we can show you, but ultimately the research, you have to do it. We can help you in that. So if you want to ask your questions, you can type in the chat box, or you can also directly interact with me. I can try to answer your queries. Okay, so let me take the questions. So one of the participants asking about why do we need to relax the structure? Basically, the relaxation is required. Sometimes we are not getting the accurate output. Let's suppose in your laptop, different folders are there, and each folders are present on different locations. Then your whole desktop are occupied. Okay, if the folders are symmetric, that are one by one, then your desktop will look nicely, and your work will be smoother, and whatever unnecessary things will be there, that will be deleted. So to optimize your structures, then relaxation is done, so that you will get more accurate results. Optimization is also required. So magnetic properties, yes, definitely. The magnetic property you can also calculate. Magnetic atom texture, magnetic movement, silver dope in tin sulfide. Yes, it is also possible. You have to create the tin sulfide, then change the replace atom. Replace atom option is there. From there you can select the atom. Let's suppose this is tin sulfide. You can select the particular atom and then click on this replace. From the periodic table, you can select the silver, and then the atom will be changed. So that type of doping can be possible. How can we calculate the band gap from band structure plot? Basically, you have to use the MATLAB. It will plot the band gap in MATLAB software. So we will show you how the MATLAB will calculate the data in the coming time. So yes, you can draw the nanostructure. Nanostructure that I have drawn to graphene like that. You can measure the distance from one point to another point. Let's suppose from this point to this point. You want to measure how much the distance. So you can see I have measured from this yellow color to this yellow color distance. Around 12.388 nanometer is the distance. So similarly, you can measure if you want to delete something, you can delete some layer. Let's suppose as an example, you want to delete this structures. 1 minute. You want to delete this outer layer. We have deleted this one. We can also delete by drawing the rectangle as well, but I have deleted one by one. Then you can click on one atom and then click on next atom. Sorry. Like that, it can be measured. So 9.947, this is the length. So by the following the same procedure, you can also perform in your computers. So can be optical absorption and emission calculation done with PLA spectra. Optical absorption, I think it is possible, but emission calculation, I don't think it is there because emitting devices is not there, but we have the software for emitting application. We also have different software. We will try to show the demo on that software that is called SATFOS. In coming days, we will explain about that. Yeah. Yes, we can simulate the composites also, MOS2, CNT, that is also possible. Hello. Someone want to ask something? Your voice is not coming, sir. Kindly check your mic, please.
Hello, sir.
Yes, sir, please.
Can we simulate FET by this NANODCAL software, sir?
Yes, it is
MOSFET.
possible. It is possible. We will show the demo on that in coming days.
Okay, sir. Like another software, can we make cavity so that we can put another dielectric material to change the characteristics, like sir, gas sensor or other things?
Can you please repeat your question once again?
Yes, sir. Like sir, gas sensor or biomolecular sensor in MOSFET design, we make a cavity so that we can put molecules over there and see the change in the characteristic of MOSFET or FinFET, whatever. So can we use that same property or that cavity-based simulation in this NANODCAL?
Yes, it is possible. It is possible. So you can simulate, you can draw it, because the interface will help you to design the structure, different FET structure. And then if you want to use for different biosensing or other application, I think it is there. But we have to understand about deeper about your particular things which you wanted to do. But some papers are there on Google Scholar. If you will put it NANODCAL on the Google Scholar, simply the NANODCAL name on Google Scholar, you will find a couple of papers to read that particular application.
Okay,
like,
sir.
Yeah,
I think I got my point that instead of SiO2, we want to change another dielectric material on the half of portion of that. Like that, I want to say that.
Yeah, you can use material, any material you can use. And also the license is also given to you so that you can also verify it yourself.
Okay, sir. Organic material also.
Yeah, exactly. Like I'm trying to search some papers on biosensing.
Yes, sir.
You can see these are some biosensor related application papers.
Sure, sir.
Mentioned.
It would help that.
Exactly. So on Google Scholar, NANODCAL or the application, whatever type of application you are working on it, you can type it and you will find a couple of papers.
Today I am working on cancer detection, sir.
Cancer detection, I am not cancer detection. We have to check it.
It's okay, sir. Like that, same as gas sensor or biomolecular sensor, like that. That is the biological part I will handle, but just not.
Yeah, some people have mentioned that H2O2 in cancer with low detection limit, NANODCAL, they have quoted in these papers. So people may be using in different application, but you have to use it. We are not sure about that.
Okay. Thank you, sir.
Thank you.
Hi. So I have this structure which that's a byproduct of a chemical reaction, and I know what it looks like on the microscopic level. Because it is visible, but I roughly have the composition of that structure. So it somewhat looks like C60, but I don't know exactly what are the lattice parameters. How different carbon atoms are placed in it. So can I use any of your tools to kind of predict what are the distances ABC of that structure?
So you want to know the structure information, input information.
Yes. So I know there are pentagons and hexagons, and it looks like a C60. I know it has a lot of carbon, but it is not C60 because there's a size difference and all that. But how do I know exactly how the different elements are placed in it?
So your questions is like a crystal structure predictor.
Yes.
Okay.
Is it possible?
I have to check it. I am not sure it is there, but I will. I have to check it. I have heard about this name, someone else, but I have not explored it. But I will explore it, and then I will try to answer you tomorrow.
All right. Thank you.
So someone is asking about demons, composites. So you can also. That's why we can try to make structures. We will try to make interface with different materials in coming sections with two material interface. And is it possible to simulate the surface adsorption calculation and work function? So we will have to look into that about adsorption and work functions, because we can calculate that is possible, but we have some tutorial is there. We will try to perform. If it is not there, we will share you some documentation tutorials, which user can also try to perform at their computer, because we have lot of tutorials, lot of videos, lot of manuals are present. We have not performed everything. We want that the user should, those who are working on different applications, they can also perform in their computers. So we will provide you all information related to your particular application where user can also perform. So today's session, I think 2.5 hours is about to over. And kindly please we come at the same time, 3 p.m. and we have a more discussion, more detailed discussion about your problems and about our softwares, how it can be better as compared to the other existing market available softwares. I believe our software will meet your expectations. So if any questions, you can ask your questions, or we can have a discussion at 3 p.m. tomorrow onwards. So yes, someone asking about academic license. The license which we have given for you, usually the trial version is for 1 month, but we have given you for 2 months so that you can fully explore it. You will not find that something you have missed it. So the trial version is for testing purpose, but for license, we have academic versions also for academic institutions. We have different price policy based on number of licenses and validity and number of licenses. We have different price policy. So we can provide you that information also, but before that we want that you should be technically satisfied with the software capability. That is very important. We have academic license options. So I think there is no more queries. So kindly, please, we will again online back tomorrow at 3 p.m. and then again continue the session. We have a couple of softwares. Maybe some of the software can meet your requirements. Okay. So thank you very much for giving your time and listening and attending the session. Thank you once again to all of you. Thank you.